All right, we're doing differentiation today. We're going to teach that. So, differentiation is sort of the concept or one of the concepts calculus is built on. And what it is, you've probably heard the word before, differentiate, derivative. But what it actually is okay, let's look at this graph f of x equals x squared. You can imagine that. And you all know how to find the slope of a graph. You just find 2 points, subtract one from one and the other from the other. You've done it a million times before. But what if you wanted to find not the slope of the whole graph, but the slope at any one given point? Let's say this point here. So if I were to draw a line that's tangential here, that we call this the tangent line, how would I find the slope here? And that's what differentiation is. So you're trying to find the slope of the tangent line at any point across the function. And you're going to do this mostly, there's a lot of things you have to remember, but the first things first, you're going to use what the derivative power rule, we call it. So the derivative power rule, if we want to find the derivative, which we write like this, of this function, x squared, you're going to need to use the power rule. And the power rule goes like this. If I want to find the derivative of n to the x power, then it's going to be equal to n times x to the n minus 1 power. So this is x to the second power right here. So we're going to take that 2 and we're going to move it out in front. And then subtract 1 from it, it'll just become x to first, which is equal to 2x. So that is our power rule, and that's how you would find the derivative of this function. And we could write it like this. We could note it as f prime of x, that's what this little thing is equal to 2x. Our trig derivatives. So these you're just going to have to memorize. And we'll start with sine of x. The derivative of sine of x is cosine x of x. The derivative of cosine x is negative sine of x. The derivative of negative sine of x is negative cosine of x. And the funny thing about this is if the derivative of negative cosine of x is sine of x, so they go in a loop. So if you just keep differentiating them, it'll be sine of x, cosine of x, minus sine of x, minus cosine of x, and right back to sine of x. And a little trick for remembering the rest of them, because they're not as straightforward, is we'll write it out like this. Secant, tangent. The derivative of tangent is secant squared. You see where I'm going with this. The derivative of secant is secant tangent. So you take anything here, the derivative is multiplied by the other two, and it works the same for our next little set. Cosine, cosecant, negative cosecant. If I ask you what the derivative of cosine, that's cotangent. Cotangent, cosecant, negative cosecant. If I ask you what the derivative of cotangent is, you multiply the other two together. It's negative cosecant squared. So you got that. You could use this little chart if you need to remember trig derivatives, and then eventually you'll get them all down. You're also going to need to know how to differentiate logarithms. So a quick and easy one, the derivative of the natural log of x is equal to 1 over x. Just remember this, you'll use it all the time. And where that actually comes from is this formula here, you could remember. The derivative of the natural log of u is equal to the derivative of u over u. So, as we can see here, it's x over the derivative of x, which is 1. And if you want to differentiate any other logarithm, we'll just go log a of x, and you want to find the derivative of this function. It'll be equal to, very similar to this, just x prime, whatever your x term is here, over the natural log of a times x. So it works like that here, but it's being multiplied by the natural log of e, which is 1. So that's how you find logarithmic derivatives. Alright, so exponential derivatives, this is the last thing we're going to cover in this video, so if you're following along, great. If not, I'd like to make more videos kind of going into each of these topics individually. It's just, I wanted to get everything in this one video if you needed a refresher, or if you just want to go through it quick. And if you need to focus more on certain aspects of this, I'll make videos for those too. But we'll get into it. Exponential derivatives, the important one to remember is that the derivative of e to the x is equal to e to the x. This is the only function like this, other than f of x is equal to 0, which is 0, but that's lame, I don't know. So e to the x is equal to e to the x, the derivative. They're same thing. You could differentiate this 100 times over, it'll be the exact same thing. And the derivative of e to any other term, we'll just say u, is equal to e to the u, just like before, but this time times the derivative of u. So it'll just be multiplied by its derivative. And you probably won't need to do this too often, but if you want to if you need to differentiate any other exponential function, like I'll just say a to the x, it's equal to a to the x multiplied by the natural log of a. The same rules here. This is being multiplied by the natural log of e, which is 1. So 2 to the x, if I want to differentiate that, it's 2 to the x times the natural log of 2. Alright, so the derivative of any constant, just call our constant c here, is always going to be 0. And the reason for this is that if I draw a graph here, we'll just say this line f of x is equal to c. Then at any point, nothing is changing. The slope is 0, thus the instantaneous rate of change is also going to be 0. So any constant will just derive right out, and you won't have to worry about it. Alright, I hope this video helped. If you learned something new from it, or if you're already doing calc, I hope this refreshed your memory of what a derivative is and a few common derivative rules. Once again, I'd like to make more videos going into further detail about some of those topics, or maybe some new calc topics, but we'll just see how this one does. Anyway, thanks for watching, making this far. I hope you understand all this. If not, I take questions. Thank you.